Okay, last time we did this exercise thing on the.
You haven't shared the solution of the first homework.
What?
You haven't shared the solution.
So what was the date for the? I think it was yesterday. Okay, send an email to Ilhan. He will share it.
Would you extend the date of the...
No? Why?
Çünkü seçimde paylaşmanız gerekiyor.
Hayır 31'inde dedim ben. Niye hayır? Yok hayır. O ödevi yapmanız gerekiyor arkadaşlar. If you don't do the first homework, you can't do the second one. It's kind of a help for those who didn't do it. I'm not saying couldn't do it. Didn't do it, okay? If you didn't do the first homework, you are very bad behind, okay? We are not going to extend the homework for the second day's due date, okay? So you are relying on that I am going to give you the first homework results. Is that what you are saying? Maybe I should stop doing that, okay? I mean, if you don't do homework number 1 because I am going to share the common code, then I am doing something bad. Maybe I should not share it at all. Yeah, I think that's what I'm going to do. Okay? Because last week on Wednesday, when I asked you to write a simple class, only 4 or 5 people were able to do it kind of okay. Some of you did not start at all. Nobody watched the videos, and it is not going very good. That's why I need to repeat the rest of this chapter. Chapter 8 now, operator overloading. And this is not what I am expecting from you. Okay? And if you do it that way, you are going to fail, and that's going to be bad both for you and worse for me.
Can I say something?
Yeah.
The reason why I want to, first of all, want the first solution of the first homework is that nobody understands what can be meant. So
how many times did I ask, are there any questions about anything? So did you ask any questions about the homework? No. The first question you ask about the homework is, are we going to get an extension for the homework number 2? Okay. I'm going to ask you again, are there any questions about homework number 1 and 2? And I discussed about homework number 2 in the class, right? People have been asking many questions about it. I were answering during the breaks or anything. And if you don't ask questions, then don't tell me that we didn't understand anything. Yes?
Can you share a couple outputs for homework 2?
Couple of outputs?
Yeah, to see what it's supposed to look like.
Okay, let's go over the homework number 2. Well, I don't want to give you the exact outputs because I like everybody to follow a different direction. If I give you such an output, it's going to be okay, because I made a decision and people are asking question about, are we going to do this exactly like that? And when I say if it's up to you, then you come back and you ask me again, how about this and this? But okay. While I am talking about, I am not going to give you any outputs, but you may ask me questions about the homework, saying that is it possible, that kind of stuff. Okay, homework number 2. Don't I have the PDF? Yeah, okay. This is number 1. This is number 2. Okay. So when the program starts, okay, you are going to ask the question. By the way, I mean, this is the driver code. You are going to give me 2 driver codes. One of them will be, don't forget about the attendance. One of them will be to test each of these functions that you are going to write, okay? each of these sub functions that you're going to write. The second one will do the simple test displaying. The first thing that you are going to ask is okay, what is the size? And the user is going to say, I don't know how you are going to get it. Maybe first you are going to ask the width of it. Maybe you are going to ask the height of it. I don't know. That's why I don't want to, for example, you said that 20 wide and 50 high, okay? Or maybe 20 by 50. I don't know, I didn't specify it. Then you are going to ask this question, okay? What is the tetris? So depending on your design, you immediately may draw a screen like this, okay? So what do I mean by drawing a screen like that? Okay, starting from your top row, okay? Starting from your top row, maybe you can say things like, okay, this is my top row, then after that I have this, okay, this is my top row, sorry. This is my top row. Okay, let me do this. I'm trying to remember, okay, good. Okay, this is my top row. Then maybe do this kind of a thing. You understand? So 20 wide and 50 high. So this is an empty. Let's say mine is very simple. Okay. Is height is just 3 and width is, I don't know, I think it is 40. This is a Tetris board. Again, you don't have to do it this way. You don't have to do it this way. It is up to you. That's why I didn't specify it. So after that, you ask the user, what is your Tetris piece, tetromino type, and the user is going to tell you either I or O or T or up to Z, okay? So you are specifying which one it is, and or user may say R for random tetromino. In that case, you are going to just pick one of them randomly, and that will be your tetromino. So what are you going to do after that? I mean, I would go back to this. And draw the tetromino at the top. Okay. Then do the rotation and the movement of the tetromino on this board, and animate it like it is dropping from the top to the bottom. So how are you going to animate it? You are going to animate it in a way that, okay, after each 50 milliseconds, you are going to draw the whole Tetris board from the top. So how are you going to do that? I gave you these ANSI codes. These ANSI codes are used for clearing the screen or moving your cursor around. Just read it, okay? And you can draw the whole board, and every time you draw it, you drop your piece one by one, and when it reaches the bottom, and you are done, okay? And you go to step 2 again. So this will continue until when? Until either the user says quit or until the board is full. Okay? So lots of things are on purpose left vaguely because, as I said, I like you to design something. If I give you the whole class, including the class function definitions, if I give you the whole algorithm, that wouldn't be like a second-year class homework, okay? That would be like first-year homework.
So can we change?
By the way, I didn't answer any questions here, okay? I just put some interpretation on my instructions. If you ask me this question again, I am going to maybe draw a different board. I don't know. Okay? So this class is not about programming, straightforward. Okay, this class is about object-oriented programming, and part of it you need to do some design, including the class design and the user interface design, maybe. All of these homeworks will be like this. Yes.
Should we put them horizontally or we should put them on another tetromino?
You mean the pieces one after the other one?
Yes.
It's going to be like a regular Tetris game. Of course, you should try to do it your best. I mean, some people have been asking me, they try to find the best fit function that will work optimally. This course is not about artificial intelligence or finding the optimal values of functions. Do the best you can. And I answered this many times to the class, and I don't want to say the same thing in the homework, because finding the best solution is not that difficult. Some of you may do it, but I don't want to force you, for all of you, to try to achieve the best possible way. But some of you I know can do it. That's why I didn't say do the best way or find the best solution or average is okay. But I mean, you don't have to find the best solution. Here I am saying it to you. Yeah.
So, as I understand from your sayings, for example, as for first homework, we don't have to follow exact input-output types for cancel function, etc. You don't have to
What do you mean follow? Of course, whatever my instruction says, definitely you're going to have a constructors for doing that. Okay, and there will be an add function for that. You have to follow the instructions, but this add function doesn't say anything about the return type. It doesn't say about first homework or second homework. Whatever the instructions say, you are going to do it. Okay, you can say that I didn't do it. I didn't choose to implement the add function and etc. Okay, do what the homework says, but the homework is written vaguely. It doesn't include any function header definitions. It doesn't even tell you what the functions return and etc. Sometimes we give the function name like the add and fit and draw, etc. That will be it. So when we grade your homeworks, okay, we are going to look at these instructions, and if one of them is missing, of course, that means that your homework is missing one of the points. Yes.
Can we carry a function of tetromino class to Tetris class? Can we modify the first homework?
Say it again.
Carry a function in the tetromino class to Tetris class.
Well, the second homework says that you are going to use, of course, the tetromino class, but it doesn't say that you are not going to modify it. Okay, if your current design requires it, yes, sure, of course. Yes. I can't hear you, sorry. No. Well, see, your question is, are we allowed to draw the Tetris board only once? No, of course not. When you go to the second step, it says you are going to animate again. So you are going to draw it over and over again so that I can see the animation. I can't hear you, sorry. I can't hear you. Say it louder, like myself. Yeah. So what are you going to do with the escape sequences? I don't exactly understand what you are asking, but animation is not a very difficult thing. All you are going to do is just draw the same thing over and over again on the screen, but starting from the top. How do you go to top? Just write the correct escape sequence. Okay, let me go there. And it will tell you why it is not happening. Same thing again. It will tell you how to clear. Does anybody of you, do any of you remember the escape code for clearing the screen on our standard terminal? What is it?
Clear.
What?
Clear.
Is the character? How do you clear the screen? Oh, you mean the issue the system command clear? Is that what you're saying? Well, you could do that, but that would make it dependent. Well, we are going to write it in Unix anyways, yeah. So this is that one, yeah. Erase the display, so it works that way. Clear, erase the display, clear, clear, clear. So how do you erase the line? What kind of, okay. So these are how you specify the stuff, attributes. So this is how you change your current font. By the way, this will work only for Unix cases, okay? It will not work for this kind of terminals, okay? My terminal here is like that kind of terminal. So our code will be dependent on Unix, okay, if you use these. And let me show you. So these are some of the escape sequences. These are for the Amiga. Yeah, okay. So these are the characters. When you print them, it's going to do this. So our new line is line feed. New line is this one, \n. Okay. Our compiler automatically changes our \n's to this character, 0x0c. Carry return is this, and I showed you, okay, the clear escape sequence a few minutes ago, somewhere there. Okay, just look. Okay, here it is. Some code, some C code. Do we have the C code? Yeah. So if you do this, see, if you do this, you are saying that I am going to print this character 033, okay, then giving this all this, remember the colors that I showed you? It will do this colorful thing. So I get this one, and after the appropriate character, you are going to clear your screen. And if you like, in this case, like you see, you may do your tetraminos in color. That will look even better, or the inverse color, like the background and foreground flipped. Again, I don't want to talk about this, and it's your task to go to this page or some other page and read this and try to understand it, find your solution, and make a different homework than the other people. Okay, any other questions? I didn't say anything new about the homework. All I said is anything, by the way, you don't have to follow this screen orientation like this I showed you. I mean, you don't have to draw a frame or anything like that. Because if I give you this kind of detail again, you're going to ask me questions about, can I use a capital letter X? Can I use this letter something, something? I don't want to get into those kind of details. Okay. Any questions? And start early. So what is the due date for homework number 2? What is the due date for the homework number 2?
November 5.
So in 5 days, yeah. You still have 5 days. Okay, let me go to this chapter number 8 again, operator overloading. As I said before, well, I didn't like what I seen on Wednesday, because nobody knew about stream insertion and extraction, okay, and only a few knew about plus plus and minus minus operators. That kind of did not work. I don't know what I am going to do. I will try it a few more times, and our TAs are preparing the indexes of the topics of the book from my videos of last year, I guess. I'm going to announce it, but I think this Wednesday I'm going to try it again to see if it is going to work a little bit better. But as I said, many of you did not know how to write a class, and almost nobody watched the videos before coming to classes. Okay, so we talked about this reference returning thing, okay, at the end of Tuesday, I guess. Okay, remember this function? It was very weird, but we are going to use it very frequently. A function that is taking a reference of a variable and returning a reference to that variable. We are going to use it like this one. Okay, tell me which one is this, okay? I keep saying this, but I am not going, I didn't tell you which one. Since I did it, we did it last time on Wednesday. Which function is this? I mean, we are going to, it is not exactly the same as this, but in spirit, it is very similar to this one. This is very similar to an operator overload that we had used. Very similar. Operator overload that we had used last time. Okay, if you don't remember it, let me.
Stream insertion.
What?
Stream insertion.
Yes, stream insertion. Say it louder. Only I could hear it. Say it louder.
Stream insertion.
Okay. Stream insertion is the stream insertion or extraction is the one that uses the exact same mechanism. You might say that this is not meaningful, but when you do, it is 6, right? Let me open this file 6. Where is it? It is not 6. 8, 7. Can't find 5. Didn't I open 5? Yeah. So let's look at this stream insertion or extraction operator. It takes a reference to an O stream object. After it uses it, it returns a reference to it. Okay? So this is very similar to what we are doing here. It takes a reference to a double variable. Well, you might say you didn't use it, but it didn't use it, but I am returning a reference to it. Why are we doing this? We are doing this kind of a design, operator overload design, so that I can do stuff like cout. What is this? Is this a money, right? Yeah. M1, then M2, then, for example, this one. Okay? So, cascaded stream insertion. Cascaded stream insertion. Why? Because this one will run first, and it will return the cout object exactly. And then this one will run, and it will return a cout object exactly. Then this one will run. That's why we have to do this kind of taking a reference in and outputting a reference out. Okay. So that was the reason, and we looked at it. And overloading stream insertion and extraction exactly works that way. And last time we discussed that we cannot overload this stream insertion overload operator as a member function. Why? Because as the first parameter, this operator takes the O stream and I stream classes. Okay, O stream is the type of the cout object. I stream is the type of the in object. Okay. So I take an O stream object on my left and a money object on my right, and I do this output thing, and then I return the all stream object so that cascaded stream insertion and extraction can be done. Okay. So let's look at the implementation again. Stream insertion. It takes the dollars part and the cents part, and it compares them against zeros, etc. If it is less than 0, then put a negative sign, and I output the dollars. And if it is greater than 10, I put a 0. If it is not, otherwise put a exactly print it out, and that will be it. See, these are output stream objects. What is the type of the output stream? It is all stream. Some of you, okay, who implemented this, okay, stream insertion operator said, okay, why don't we use cout instead of output stream all the time, like that, okay? And even I tried it and it works, you might say that. So what was the problem with this approach? Instead of output stream, use cout. Yes?
We may not instruct the C out all the time.
Yeah, we cannot use our stream insertion object for any object other than the cout. Okay, so cout is automatically connected to the standard output. But if I like to change my output direction from standard output to, let's say, some file. Remember, we opened a file. Remember how we did the files? I think it was at the end of chapter what? Opening a file. It was at the end of chapter 3, maybe. I don't remember. Any of you remember? Chapter 4, maybe the last one of the chapter. No. Chapter 5. I think it was earlier than that. Chapter 3. Remember how we did the Nobody remembers it?
Creating an object.
What?
First creating an object and using open.
Yeah. Well, I like to show you the code. It was at the end of chapter number 2, maybe. Is it too early? Chapter number 2, like the example 12, 11. Yeah. Okay. So see this one? I open the file. File is connected to player.txt, and I keep reading from input stream. Input stream is my I stream. What is the type of I stream? Well, it says F stream, but F stream is also I stream too. In C++, we can do those kind of tricks, and we are going to see. So I'm reading from input stream, not from CN. Surprise, if you overload the stream extraction operator for the money class, you can read and write your money objects to a txt file, okay? Because you overloaded the stream insertion extraction operator. You overloaded it for the OStream and iStream classes, and it will work for any kind of file that you open this way. I open this file on my desk. I can open this file on a network drive, or I can open this file on a network connection, okay? I can read all those characters from a network connection, and it will work. It will work. So we are doing it. We are doing it for a general kind of usage, stream insertion and extraction. That's why you can say, I am only dependent on cout object. Okay. So the correct thing is use output stream here, output stream here, output stream, and output stream, and you return an output stream. Okay?
So we can use them like cascading, right?
Well, if you say cout here, yes, it will work for the cout cascading, right? Cout something, 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 it will work. But if you do it this way, this one will work for any case, including the cascaded operations or the file input outputs or the network input output and etc. This one will work. Okay, so that was the stream insertion and extraction discussion. That's how we overload it. There are two things important. One is, why can't we overload the stream insertion and extraction as a member function? It can't, because the first parameter, the left hand side parameter of these operators, are not our classes. They are iStream and allStream classes. And then the second important concept here is, why are we taking a reference and returning a reference? That was the reason. Remember what we said about the friends, okay? Or let's, okay. Before the friends, we had a discussion. We said that overloading, okay, operator which method? Of course, we prefer member operators, okay? Member operators, they are more object-oriented. They are object-oriented. Global operators, they are not object-oriented. But sometimes we have to use the global operators. And sometimes it is, we use them for their efficiency, okay? But in the case of stream insertion and extraction, we use them because we have to. Otherwise, we cannot overload stream insertion and extraction. Okay, good. So it makes sense to, after you understand the whole chapter, okay, it makes sense to go back and read the chapter from the beginning or the other chapters. It makes more sense. Why? Oh, that's why we are doing this. That's why we have this and this, etc. Okay, so we looked at the stream insertion and extraction. Assignment operator, we did not give any examples of it. We don't need for now the assignment operator. But the thing is this, let's go back to my favorite class. Okay, my favorite class, remember, A. Okay, so this is my favorite class definition. Remember, we said that even though it looks empty, it is not empty. There are many things defined on it, right? Because I can say things like A1, A2. What does that mean? It means that this class A has a default constructor, right? It has a default constructor. So somebody has defined a default constructor for me. That's one thing. The other thing is that this operator works. A star, A pointer is address of A1. So this operator, somebody defined this address of operator or ampersand operator for this class. It works. I know that, okay? But I know that this one will not work. A1 plus A2. This one will not work because nobody implemented it. Nobody implemented it. What else? Why are we talking about this again? This one will work. A1 gets the value of A2. This one will work because there is a default assignment operator. There is a default assignment operator implemented for this class. Okay, what does it do? It does the member-wise copy. Okay, it does member-wise copy. What is member-wise copy? Whatever I have inside this A1, A2 will be copied to A1. Well, in this case, I don't have anything. I don't have anything in it. Nothing will be copied. But if you say money M1 and M2, when you say, okay, maybe let's make some M100, M2 is $10.20. So what are we going to have in our memory? In our memory, in M1, M1 will be, remember, 0, 0. This is my M1. My M2 will be $10.20, right? So member-wise copy will do this. M1 gets the value of M2. It will assign this 10 to this part and 2 to this part. Okay, that's what member-wise copy is. Okay, run the assignment operator for each data member of the class. That's what you do. Run the assignment operator for each data member of the class, for each object. That's the member-wise copy. So most of the time, this default behavior is okay with us. It is just copying all the data one by one. But as we are going to see in the next chapter, it will not work for some cases. Okay, it will give us very, very big trouble. Okay, especially with the pointers. We are going to come to that. So that's why sometimes we have to overload the assignment operator. I am not going to overload anything right now, okay, because it doesn't make much sense to overload something that is already working fine. So we are going to do it in the next case. But we will be very careful about this kind of a syntax. So this should happen, right? That's why I should return something out of this assignment operator so that this notation can work. By the way, the associativity of the assignment operator is from right to left, right? So this one will be done first, then this one. And remember, operator overloading rules, you cannot change the associativity. But when you say cout A and B, it will be like this, because the associativity for the stream insertion operator is left to right. Okay. So I think this assignment operator is the only operator in C and C++ that does right to left ordering of the operators. Yes?
Should we need to make a new operator overloading for stream extraction? Oh, sorry. If we do C in stream insertion, A stream insertion, should we make a new operator overloading for stream insertion operator for money to money object? Should we need to?
Does this make any sense? Let's say M1 and M2 are money, right? Does this make any sense? What does this mean?
No,
It makes, if this one makes sense, then you do, yeah. But it doesn't make any sense, right?
like assign cascade.
What?
Like cascade assignments.
Yeah, but cascade assignment works, yes. That's why maybe you are asking this. This doesn't make any sense, so I don't overload it this way, okay? So what do I mean by this? I mean left shift, right shift, put something on. No, don't overload. Well, it is okay to overload it, but don't overload it because it makes it very confusing. This one, but is something that we like, that we use all the time, okay? So you should overload it this way. That means what? Type of A is money, type of B is money, type of C is money. So since both of them are the same type, I can overload this as a member function. And in fact, remember the rules, assignment operator should be overloaded as a member function. Okay? Any questions? Good. So I am going to delay discussion about the assignment overloads for the next chapter. We are going to look at it more carefully in that one, and it's going to be more involved. For now, the default behavior of assignment operator works. Okay, so I am going to come back to this class A empty class, and we already talked about the default constructors, default assignment operator, and there is a default copy constructor. There is another constructor that works automatically, and let me tell you what. When you say this one A1, A2, right? And I am going to make this A3, A3, A1. It looks like there is a constructor, okay, that takes a copy of another object of this class, okay, another object of this class, and it will copy its contents to this object A3. And you might say that I didn't write such a constructor, but it works, okay? That's called copy constructor, okay? So the copy constructor, there is a default copy constructor, default assignment operator, and the address operator. These are the things that will work for this class A. We call these, okay, default constructor, default copy constructor, default assignment operators, big 3. Okay, these are big 3, and most of the time, if your classes are very simple, the default meanings are okay. But if your classes are not simple, they involve pointers, they involve other stuff, then big 3 needs to be overloaded, or big 3 needs to be implemented, sorry. And you need to put it in the comment section of your class saying that I implemented the big 3 and etc. Again, we are going to come back to this in chapter number 10.
So can we say that class constructors shouldn't has reference in them, right?
Where did you get that?
We say A2, parentheses A1. If
Yeah.
we define constructor with references, then when we change A1, A3 also automatically change, right?
I didn't say anything like that, but yeah, if you like to. So the question you're asking is not about big 3. The question you're asking is, can I build such a constructor? And yes, we will talk about it. Sometimes you should. And in fact, this copy constructor is written by taking a reference. The reason it will be clear when we talk about it. Okay, and increment and decrement operators. So these are, both of them are unary operators. So how are we going to know the difference between them? Because remember, what does the C++ do? Whenever it sees it, it's going to say x plus operator plus plus and no parameters. And this one is going to be x plus operator plus plus. So it means what? I am going to overload exactly the same thing. If I overload exactly the same thing, it will be a single overload. So how does the compiler know the difference between them? So compiler say that, no, I am going to call this one. I am going to call this one if I see a post increment or post decrement operators. So I am going to send an extra integer. Even though there are no integers involved, I am going to send an extra integer so that when you overload such a function, it means prefix. When you overload such a function, it means postfix. Okay, that's what the meaning of increment and decrement. And I think in the book there was an example. It was 7. No, this is the index. It was 6 maybe. Yeah. So remember this simple class int pair. It's going to represent a pair of integers. Okay. It's going to represent a pair of integers. And I think the meaning of plus plus is increment. Let's look at the meaning of, yeah. It increments the first those two elements at the same time. But okay, let's look at the driver code first. I have an array of int pairs, hundreds of them, 100 of them, that's fine. I have an integer pair, a1, 2. The first element is 1, the second is 2. And get first, get second. So tell me what What am I going to see on the screen now? Line 25. This one will print on the screen. It will print one space 2, right? Okay, this will be fine. How about this one? This one says that assignment operator, even though I didn't overload it, the default meaning is there. Okay, it says that B gets the value of A plus plus. What is the meaning of A plus plus? Increment the first and second. So 1 will become 2, 2 will become 3, right? But this one says that do whatever you are doing, okay, do whatever you are doing, but return me the original value of A. What is the original value of A? 1 and 2. So this one will increment. First, it will increment value of A by 1. A becomes 1 and 2, 2 and 3, but it will return the original version, which is 1 and 2. So B will be 1 and 2. So this one will print 1 and 2 on the screen, right? Yes.
So plus A will not work either, right?
The
Plus A will not work either because we are returning the original value of A.
well, for A plus plus, yes, but I did not show you plus plus A yet. I didn't show you the implementation. Okay, so this one will print 1 and 2 on the screen, but this one will print 2 and 3 on the screen, right? So let's do this again. A again is 1, 2. This will print 1, 2 on the screen. How about this one? This one says that increment A first, so A becomes 2 and 3, and then return the incremented version of A. So it will return the incremented version of A. C becomes 2 and 3. So this will print 2 and 3, and this will print 2 and 3. Okay, so I am not sure if this is compilable. Let me try to compile it. Let me try to compile it. Execute and run. Okay, yeah. So the value of A is 1, 2. Then remember that assignment, B gets the value of A plus plus. B is 1, 2, but A is 2, 3. So this one is plus plus A. The original value of A is 1, 2. So the returned value is 2, 3, because B gets the value of plus plus A is 2, 3 and 2, 3. Okay. So let's look at the implementation. Implementation is this. Okay, so this is the postfix version. What does it mean? Increment the object first, but return the original one. So I get the copies backup of the data first and second. I increment first, I increment second. Okay, so my object is incremented, I know, but I am returning a copy of the original. Okay, so this is the postfix. Prefix is I increment myself, but I return the same object exactly the same as me. Okay, so the prefix version is cheaper to run. Why? Because it doesn't take the backup. This one takes the backup. So that's why we always try to, if we are using these two operators by themselves in isolation, so we try to use plus plus I instead of I plus plus. That's what Google said, right? Google style. Remember that? That's what it said. Okay, so this is the index operator, the incrementation or decrementation operator, post and prefix. That's how they work. Any questions? So this is a bad thing. This is a bad thing when you say A plus 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 plus. Why is this a bad thing? First of all, does it compile? I don't know. It may not compile at all, but even if it compiles, what?
Undefined behavior, I think. Undefined behavior, I think.
No, well,
It's compile and run.
I don't think that is undefined. Why? Because this one will be done first, then this one will be done next. But
put parentheses around.
so you are saying that to make this one, well, I'm telling you, this one will be done first. Whatever it returns, this one will be done next. But what does this return? It returns a copy of something, like a temporary copy of something, right? So you are incrementing something temporary. It will be a bad thing. It will be a bad thing. How about this one? Plus, 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 plus a. Now this one is kind of troublesome. This one returns exactly the same as me. Well, is it my copy or is it myself? Okay, that depends on the implementation. If it is myself, then this one will work. If it's a copy, then it's going to be a problem. But don't write any of them, right? This one is bad, and this one is kind of bad. It may work, so it is green bad, but both of them are bad. Confusing, very confusing, and don't do that. Well, plus, that's a good question. Plus, plus a, and plus, plus. Looks symmetric and nice. So how about this? Remember the precedence of the operators? Prefix is done first and the postfix later. That's what's going to be. Okay? So this one will be done first. So it will return the object itself, and this one will be done next. Again, but don't do this. Okay? Don't do this. I am not sure. I think it will compile because, again, it depends on, if we are talking about the integers, it will compile. But if we are talking about the pair index stuff, remember this one? If I return constant, okay, if I return constant integer pairs out of these operators, none of them will work because those are constants. It depends on your implementation. And we are going to come back to this plus plus later at the end of chapter number 10 when we talk about the pointers. Okay, so at the end of this chapter, we will talk about index operators. But for that, maybe I should take some break. After the break, we will continue on this. Tabii, ne yapıyorsun? C'in A diyorsun, sonra da B diyorsun. C'in A ne yapıyor? Çalışıyor, kendisi bir tane C'in return ediyor. O da B'ye gidiyor.
Hocam sınav tarihi belli mi? Sınav tarihi belli oldu mu?
Haftaya mı yapacaktık bugün? Bu 6. hafta mı bu hafta?
Evet hocam 6. hafta.
Tamam, konuşalım dersi, bir daha hatırlat.
Tamam.
Öyle diyorsunuz, tamam diyorsunuz, hatırlatmıyorsunuz.
Hatırlatacağım hocam, merak etmeyin.
Tamam.
Hocam ödevde 2 header 2 CP demişsin de ben başka bir header CP ile koyabilir miyim?
Ne? Ha, olur, tamam. En az onlar lazım ama.
Hocam sınav tarihi 7'si gözüküyor da o netleşecek mi?
Onu konuşacağız, derste hatırlatacak arkadaşlar. Sen de hatırlat.
Hocam yoklama kağıdına imza atabilir miyim?
Yoklamaya imza mı atacaksın? Yoklama kağıdı yok ki. Onu iptal edip 3 hafta oldu. Sen imza atmadın mı online?
Yani eğer öyle açılıyorsa yani eğer açılan şey yoksa ben boşuna keşke başlasaydım. Sarı tanımları var yani. Şunu da ben kapatayım. Bunu da yazıyorum. Şunu da ben burada yazıyorum zaten. Fonksiyonları burada kendi gelecek. Burada bir şey gelecek. Bir sürü. Hayır, ben de görecek biraz en düşünüyorum. Yani şey sıkıntı, düşünmüştüm aslında. Biri giden kodaymış aslında değil mi? Bir satır çıktı. Evet, çok istiyormuş aslında. Evet, bu kendisi çok iyi tekrarlıyor ve tekrarlıyor. Kendimi baş yapmıştım. Ben yine yoksa siz yapmadığınızı yapmayı zaten yazamadım. Güzel önce siz oldu. Bir şey yazamadım.
Yaptım ondan sonra çarşambadan 12'den sonra bir de vektör mü adresini dolduruyorum değil. Şey yapıyorlar. Aslında işte bir de ekiplerin sonuçlarında da internette falan var. Çünkü şey süreçte kolay geçen gün öyle geçen internet çözüm kitabı geçiyor. Zaten çözüm var. Çözüme gerek yok. Anlamadan çözüm direkt şey alıyor. 10 tane son sorusu da şey. Geri kalan. Şey var, internet şey daha gelmeyeceğim.
Okay, our midterm exam. I can do the midterm exam next week. Okay, next week, which is today is 31st. Next week is going to be 7th. Okay, it is November 7th. Is it okay? Can we do it on November 7th? I think do we have enough rooms? Did you guys see anybody lecturing in the other larger rooms? Did you see it? Well, I don't know about the time, but the November 7th or the alternative would be November 15th. How about your math and physics classes or service classes? What time, what date are they doing their exams? What? Anybody taking math? Mathematics, calculus class? November 24th? Really? No, I'm talking about the Math 101, 102. Math 101, 102. Anybody? Okay, so everybody passed those courses? Oh, that's a surprise. That's good. Or you didn't take it yet. Okay, which one? November 7, raise your hands. November 7, November 15, raise your hands. Okay. Okay, November 15th. November 15th. I was worried that nobody would raise their hands for November 15th either. So. Okay. What happened? Niye konuşuyor bunlar? Okay, let's go back to our lecture. Index operator is a binary operator, right? It is A7. Okay? Whatever the meaning of A, whatever the type of A, I don't know. It usually associated with the arrays or array kind of thing. For the money class, it doesn't make much sense, right? For the money class, it doesn't make any sense. Let's say M1 is a money object. Maybe M11 is dollars part. Maybe, oh, how about this one? Can I overload it this way? It's an original overload. M1 is a money object. When I say M1 dollars, $7. How about, okay? And M1 cents is 20 cents. Does it look good? Weird. If you like to overload it, yes, you can overload it that way. In fact, let me overload it. Let me go to the money class, if I can find it. Yeah, this is my money class. See, I have my dollars and cents. I am going to overload it here, and I'm going to tell you the things that you can do in C++ and the things that you shouldn't do, even though you can do. You can do doesn't mean that you should do it. Okay, so operator index. Okay, of course, it's going to take, in this case, a character C. What am I going to return? Okay, I'm going to return an integer, right? But I'm going to return an integer reference so that I can modify it. Is this going to be a constant function? No. Well, I think I'm going to do both of them. Okay, Control V. Okay, so I am going to return a constant reference to my integer and constant. Okay, good. So both of them. So these have two different signatures. Okay. Don't forget about your online attendance. Okay, so these two are different signatures. One is remember, in the signature, I'm going to ignore the returning part. Only this part is important. So the type of the parameters, order of the parameters, and their constantness. Okay, so this is a constant function. It has a different signature than the other one. So let's implement this one. So how am I going to implement it? I am going to implement it like this. I am going to return an integer reference. Of course, it is part of the money class. Okay. By the way, I guess Ilhan Ilham shared the homework number 1 from one of our classmates by taking his permission. He said that he already shared the header file. Now he's sharing the whole CPP file. That doesn't mean that the code that we shared is the correct interpretation, or it should be exactly this way or thing. It is our friend's interpretation, and that's fine. It's one of the solutions. So if switch, maybe switch is good, right? Switch C and case my, where is my, case, if it is $D, then return dollars part. Is it, what was the name of the private? Okay, dollars. See, I cannot say get dollars here. Why can I say get dollars? I cannot use, remember my suggestion, always use a public interface. I cannot say get dollars because I am returning a reference, right? I need to return a reference to my, to my data so that I can return a reference to it. And this one is going to be C for the cents. I am returning a reference to my cents, and I am not going to use any break statements because they are returning it. Okay, and by default, I am going to say, exit -1. Other than these two, exit -1. That will be it. Okay, so this is the one that returns dollars part or the cents part. I overloaded it this way, and I can do stuff like, I can do stuff like cout your amount dot, your amount, not dot, but C, give me the cents of your amount. As I said, I mean, if somebody who's reading this line 58, when you look at it, doesn't make much sense unless you look at the implementation. What does that mean? If I need to look at the implementation to understand what a function does, that means that I didn't write object-oriented code, because I don't have to know the implementation or the details of how a function works. This one looks fine, minus for the money, it works fine, right? I mean, yeah, just subtract this amount from this one, add these together, it makes sense. Or this one, stream insertion, I am going to write money on the screen, or the standard output, whatever. This one, a money that takes a character as a index parameter, doesn't make much sense. When you look at the implementation, you might say, well, after the implementation, maybe it makes sense. So I have implemented this way. The point I am trying to make is operator overloading is something nice if you do it right. If you don't do it right, your code still compiles and runs, but your code might be unreadable, Your code might be unreadable. Instead of doing this this way, you could just say your amount dot get cents, right? Much more readable, So don't do 58 to 59. Don't abuse operator overloading mechanism. It's not going to be good for you. It's not understandable code. It's not a useful code, line 58. But this was a good example for me, so that, I mean, you don't have to use index integer for for this index operator. It can be a character, it can be another money, okay? It can be anything because it's your function now. By the way, I think I wouldn't implement this one. I wouldn't implement this one line 19 because I don't want to write anything like this. My amount, index operator, dollars part, okay, is minus 34. If I implement that line, this would have been possible, but this is a serious violation of the object-oriented programming rules. Why? Because I am exposing my internal data to outside world, and this guy is making this minus 34. Remember my rule? My rule was always keep cents part and the dollars part with the same sign. If one of them is positive, the other one has to be positive. If one of them is negative, the other one has to be negative, right? In this case, I am breaking that rule because I am letting somebody else to play with my internal data, okay? So if I don't overload this, get rid of this one, all I am doing is returning a constant reference, and constant references cannot be changed, modified. Still, line 19 is a bad thing, but at least not as bad as line, okay, line 20 is a bad thing, but it is not as bad as line 19. Okay? Yes?
We returning a reference, but am I wondering, can we control the flow of assignments?
No. Assignment operator is for the integers, right? I am returning an integer value, and whatever I assign with the integer value is something to do with the integer class. An integer class is not my class. For an integer class, negatives and positives are the same thing. Okay? Yes? Plus assignment, sure, yeah. Well, plus assignment, yeah. Well, how am I going to do the plus assignment? Let's overload the plus assignment operator. That's going to be, so what should that, operator plus assignment, okay? So it should take a constant money reference, other, right? And it's a constant function, and let's implement it here. What am I going to do? How am I going to do that? So plus assignment is I am going to add the other to myself, right? I am going to add the other to myself, and myself will be modified. So this cannot be a const function, right? I am going to be modified. And I should return a money object, like this one, okay? So how am I gonna do this? I can increment, can I do that? So I need to convert it to, I'm trying to see if I can do it in a short way. Using this pointer, I can do it in a very short way, but you don't know how to use this. I'm going to leave the implementation for you. It's going to be very similar to this plus and minus. Where is my plus and minus? Okay. So all cents, and after that I am going to do this, and I am going to make this assignment. My cents will be this, and my dollars will be this, and I am going to return a money object. Of course, you can overload. So the question was, can I overload this operator? Yes, you can overload it, but it's not going to be a constant function. Again, it is up to you. You can make this a constant function. You don't modify anything. Or this would be my, okay, this would be my void, and cout This would be my implementation. 1, 2, 3. Yeah, that's it. Would compiler say anything about this? No. It will compile and it will run. Does it make any sense? Of course not. I mean, plus assignment means something. I am expecting to modify myself and do something with my data. It's not doing it. Compiler will not object. Okay. So this is a compilable code, but inherently it's a very bad code. Yeah.
Do we need to overload it to be able to use plus assign?
Do we need to overload what?
Do we need to define plus assignment?
No. Compiler doesn't know that plus assignment and plus operators are related. For compiler, they are two different unrelated operators. So you might think that when you overload plus operator, plus assignment is automatically overloaded, or I should overload them in a compatible way. No, you don't have to. Compiler doesn't know that plus assignment and plus are related.
Like, isn't the equal of object plus assignment other object gets assigned the value of object plus other? So they are converted.
Yeah, well, yeah, sure. Yeah, you should get a help from the plus operator if you use this pointer. Yes. I mean, yeah, definitely. I can do, for example, here. I can say with the plus operator, I can say, okay, a new object. I don't want to do this, but money new is star this plus other. Okay, and I am going to make this. This is bad code, but okay. This is an and return star this. So this whole implementation is, and in fact I can do this too. Okay. So this is the whole thing. So I am using the plus operator here. It will work. But again, you don't have to. Compiler doesn't associate plus or assignment with assignment or plus operators. It's just an operator. It is up to you what kind of meaning you are going to give the operator overloads. The compiler doesn't, even the type of the parameter, return type, etc. They are all up to you. Okay, good. So this was a discussion about the index operator. We talked about it, and let's go back. We looked at the index operator. By the way, yeah, these are two different things. Function f has two signatures here. They are overloaded. So this one can be used anywhere in an L value or F value. So I can say C out F, it will work. Or you can say F gets the value of 7, it will work too. So F can be used as an L value or R value. Here it's an R value, here is an L value. Our index operator is like that too. This index operator that we define. So yeah, this one is an R value constant. This one is an L value. I think in the book it is a little bit, yeah. This character pair is like integer pair. There is nothing in it. Okay, so this one works this way. Okay, so this one will return a reference to the first one. I get. Oh no. Let's look at the implementation. Yeah. Implementation of this one. It's going to take an index. If index 1, it returns a reference to the first. Otherwise, it reference to the second. Okay, but it returns a constant reference. So whatever I am returning, it cannot be modified. How about the other overload? Other overload is exactly the same as this. It returns a reference, but it is not. Why did I do this? Okay, it returns a non-const reference to the first or second. And at the end of this chapter, okay, more examples. This returns a value. This returns a constant value, reference, constant reference. Of course, we like to return constant references because nobody can modify them and there is no copying. But to return a reference, that object has to be in the memory all the time. You cannot return a reference to a local object, so it has to be a copy. That's why sometimes we have to return it this way or that way. Okay, so the one that I like most is this one, but sometimes I cannot return a reference to a local object. In that case, I am going to return a copy. Okay, this one returns a value, right? This is reference, this is value. Value makes a copy. Okay, so that's it for this, for the chapter number 8. Any questions? Yes.
Why put const at the left side of
Say it again.
There's a const, even though we are sending a copy. Why is there a const?
Well, remember we discussed this one. Remember, what do we say? Yeah, money 1 plus money 2. Remember, it returns a money object, and we made it constant so that nobody can do this.
But I think we put the const at the right side.
That const is that this function will not modify this object. This const is whatever I am returning, you cannot modify it. So we don't want to do that. Okay, that's why we do it this way. Yes?
Does it make sense to sending reference with const? Why do we sending reference if we are not going to change it?
You mean this one?
Yes.
It is exactly the same reason why we did this. In this case, I am returning a reference to my first or second, and you cannot change it. If I like to use it that way, okay? So for what cases I am going to use this one? I am going to use that one for this kind of character pairs. With this character pair, the character pair is a constant character pair, okay? I can't do CP1, okay? This is okay, this one is okay, this one is okay. But if I like to modify CP1 using this notation, I will get an error message because CP is a constant character pair. Okay? Without running these programs, without playing with them, without experimenting with how about this kind of exercising, nothing will be clear in your head. You will always ask questions like, how about this one? Oh, okay. How about this one? Oh, okay. How about this one? And you're going to realize that you keep asking the different forms of the same question over and over again. Okay? And after that, you will be fine after a few hours.
Isn't should be C in insertion for error?
What do you mean?
You say
C in when I do this, C in like this one. So what are you saying? So this one is okay because A is not a constant, and when I do this, this overload will work. It is returning a non-const modifiable character reference. But if you do this, control Y, control, how come, why I'm not, this is not copying it, control C, where is copy? Copy is control C, how come it is not, okay. So if you do this, this will give you a compiler error because.
But you said line line 28 gives error because it's constant.
What did I say? Line 20 what?
CDQ, CP1.
Why don't you speak up so that everybody can hear you?
I heard, as you said, CP1 gives error for line 28, but it shouldn't because it's just
Line 28, I just type it up. This one is not an error. Well, this one is okay. This one is okay. This one is okay. This one is not okay. This is an error message. Why is this not okay? Because this one is not returning a const reference. This one is returning a const reference. Okay, so that's the end of the chapter. So go back and read the chapter. As I said before, you don't need to overload any operators to write any code in C++ or to write object-oriented code. You don't need operator overloading. So why did we talk about this? Because we learned about the references better. We learned about returning references from a class. We learned about the better behavior of the plus, plus, minus, minus operators, and that kind of stuff. Okay. And as far as I know, most of the C++ classes around in this country, they skip this chapter, but I don't want to skip it. In fact, I like to spend more time on it. That doesn't mean that you should use operator overloading all the time, but you should know the details of it. Okay, why that there are friend functions, why we shouldn't use them, and why sometimes we have to use them. Okay, let me continue with the next chapter, which is, well, the next chapter is about strings. You already knew about the strings, so I am not going to talk about them. In fact, maybe I will ask you to read about strings, and I am going to do some. Oh, okay, so you read about the strings. You watch my videos from last year about strings, maybe 2 years ago, I don't know, because I think last year I didn't talk about strings either. And on Wednesday, we will do some programming about strings. We will do exactly the same thing. So read chapter number 9 about strings. Come back to class that way. And we are going to use exactly the same groups. This time, let's switch the group number 1 with the number 2. So 9:30 and 8:30 switched, so that those people don't have to come too early all the time. So Wednesday, we are going to do it that way. I'm going to skip this one, and I'm going to start chapter number 10, which is about pointers. Chapter number 10, which is about pointers and using pointers in our classes, which will make sense in terms of using copy constructors and etc. Pointers are, my point is always this: pointers are, okay, not any different than integers. That's what that's what I keep saying all the time. When you say I have two integers, I and j, and the initial value of I is 10, initial value of j is I plus 7, this is what happens, right? In my memory, two locations are reserved for two integers, I and j. Okay, I and j. And then I get the value of 10 and j gets the value of 17. That will be the case. And I can do many things like incrementing the value of I, outputting j, and etc. So because there are many things that I can do on integers, because integer is a known type, plus and minus and multiplication, they are all overloaded for the integer types, okay? And since these two have locations in my memory, the compiler knows their location. For example, I lives at this location. Let's say it is A2B0. It's an hexadecimal location. So Similarly, I can do stuff like this. IPTR is a variable, its type is an integer pointer. It's not an integer, it's a pointer. And when I do that, compiler says that, okay, your IPTR will live at this position in this memory. Its position will be B570. But then I make this assignment. Get the address of I, which is this one, and put it in this IPR here, okay? So it's an assignment, like this assignment, integer assignment. This is a pointer assignment, address assignment, okay? And the meaning of assignment is always the same, is almost the same, okay? It is almost the same. So I put this value in here. My point here is, like I am doing operations with an integer, I am doing operations with pointers. This is an integer type. This is an integer pointer type. I could have another object of many type, right? So it's a simple declaration, simple declaration. I can do addition, okay? Addition with integers. I can do addition. The plus operator works with pointers, but its meaning is kind of different. Its meaning is not like integer addition. What is IPTR plus 3? You know the meaning of it from your C programming course. Its meaning is add 3 integer positions to this IPTR. The size of integer is, let's say, 4 bytes for my architecture, for my compiler, for my operating system. So it's going to be 3 times 4, 12 bytes will be added to the IPTR. And IP2 is another integer pointer. So IP2 will be some space allocated for IP2. And this value will be put into this position. So it looks like A2, B0, I added 12 on it. It's going to be A2, BC, right? I added 12 on it, and IP2 became, took a value, okay? So my whole point is this. There are integers are very simple classes. Integer pointers are simple classes too. But there are operators that works on the integers, plus, minus, multiplication, division. There are operators that works on the integer pointers too, like the assignment and the plus operator, etc. Minus doesn't work with the pointers, right? Unary minus doesn't work with the pointers, but unary minus works with the integers, etc. So let's try to compare them a little bit. Binary plus works with the integers, okay? It works with the integer pointers too. Unary plus works with the integers, right? You can say plus 7, but it doesn't work with the integer pointers. Binary multiplication works with the integers. It doesn't work the pointers, but the opposite, unary multiplication or unary star or asterisk, okay? It doesn't work with integers, but it works with the pointers. Remember, this one, you can say stuff like cout star integer PTR. If this integer PTR is an integer pointer, okay, this unary star operator will work on it. But unary star will not work for the integers. Modulo operator works for the integers. This one doesn't work. Binary AND operator. Remember binary AND operator? It takes the bitwise AND of 2 integers. It will work for the integers, okay, but it will not work for the integer pointers. Unary address operator will work both of them. So it doesn't make much sense to continue, but as I said, I mean, integer is a class that can take all these operators. Integer pointer is a class that takes all these operators. Some of the operators will work both of them, some of them will not. Okay, so all you need to do is just learn the meaning of each of these operators, and like you are doing programming with integers, do your programming with integer pointers or any other pointers. That's what I am saying. So pointers are not complicated. They are just different classes. they have their own behavior. Like the behavior of a money class is different than behavior of the integer class, right? The meaning of plus is very different than the meaning of plus for the doubles or the characters. It changes. So all you need to do is just learn all those behaviors and do some programming, and you'll be fine. Don't be scared about pointers. Don't say that they are complicated. Don't say that it is difficult to write programs with the pointers. Okay, so we will continue working on this topic, pointers, and let's see a few examples on pointers. Let me go to this chapter number. Okay, chapter number 10. Okay, here is an example. Very simple one. I don't want. Do I want to do it? No, I don't want to do that because it talks about this new. Remember what we did in C? Let's talk about this one. In C, if we like to allocate some space for a integer array of money objects, this is what we used to do. Remember this one? Memory allocation function, which is part of the standard library of C. Allocate me, okay, 100 times size of money positions in the heap, okay? It's going to return a void pointer to you, and you are going to cast it to a money pointer, and I am going to point it with a money pointer now, okay? This is how we do the dynamic allocation for money objects. And whenever we are done with this position, with this memory, allocated memory, we free them, right? In C++, we have a new operator, and its name is new. This is an operator, okay? It's an operator, so it's part of the language now. malloc is not part of the language, it's part of the library. It's a function. Free is a function. Now, new is a new keyword. Okay, it's a new keyword. When you say new money 100, okay, it reserves 100 money positions in my heap. It calls 100 no parameter constructors on them. It initializes them, and you are using this MP, okay, to point to that location, that 100 money objects, and use it the way you want as an array. Whenever you are done, you are going to, well, this is kind of, let me do it this way. A little bit missing here, but just for now, let's say it's true. You are going to use this to deallocate the space that you have allocated. So we are not going to use these two C functions anymore, malloc and free. Okay, we are going to use these two new keywords, delete and new. Okay, so that's going to be our new allocation stuff. Yes.
Can we use constructor parameter?
I think somebody has asked this. No, it has to be no parameter constructor. It has to be no parameter constructor. So if you don't have any constructors that doesn't take any parameters, making an array of your objects will not be possible. In that case, you would use vectors. Yes?
Is it dynamic?
Of course, it is. Malloc, is malloc dynamic?
Yes.
Yeah, it's the same thing.
And can I allocate without a working constructor? Only
No. In object-oriented programming languages, it's a bad thing to have uninitialized objects. Don't do that. Well, I mean, if you run this doesn't call any constructors. It just allocates space for you, but it's a bad thing. Don't do this. It is possible, but don't do it. Always initialize your objects. Okay, that's it for today. I'm going to continue tomorrow morning.
Hocam referans değişkenine gibi yapabiliyor muyuz?